Okay, here's a quick video introduction on how to use graphical analysis. You find the graphical analysis icon and you click on it. It may or may not come up with this picture, but if it does, we want to click on the built-in sensors and we want manual entry. We're going to enter some data. Once you get manual entry, it looks just like a two-column spreadsheet, and you tap in one of the cells and then you just start typing in numbers. They're not cursors, so it's kind of a pain to come straight down the column, but you can highlight something and you can cut it and you can delete it. It's pretty usable. Now, rather than take all the time and enter that, I'm going to go to some data I've already entered. So I click down the clock. Everything you ever enter gets saved on this, which is good, but it's also a nuisance in that you get lots and lots of extra data, but we won't worry about that. So I think this is the one I want. Yep. So once you enter in the data, then I want to graph it. I go over here to the little curly wave form and I click on it, and it gives me the choices. Table is what we're at now. Meters was what we started at. And then you do one graph, two graphs, and three graphs on the same sheet. Okay, we're going to do one graph today. We'll learn how to do the other stuff later. This is a little picture that highlights the whole thing, that does a connect the dots. I hate it. I assume it's useful for some reason. Then we want to highlight all the dots. Sometimes it's easier. You guys are used to iPads to squeeze it in a little bit. My fingers are fat, so I kind of do that. Then you highlight the dots you want to collect, that you want to make a best fit line. Now we have several choices. You click on the highlighted area, and now I have all these choices. I've got statistics over here. You may or may not have that on. We don't really need that right now, so I'm going to turn the statistics off. I can have a proportional line, which is just y equals mx, except the y-intercept is b. We have a linear, which should fit this one pretty well. So once you find one, you have quadratic. And the problem with quadratic is you can make a quadratic fit almost any collection of dots you have, whether it's actually a quadratic function or not. So we will avoid using quadratic. In fact, unless I tell you otherwise, never choose quadratic. You have a power and we have a variable power. We're going to look at those in a second. But for this example, I'm going to show you linear. So I choose the linear, I click add, and there I have that's the best fit line. It tells me what the formula is. Y equals mx plus b gives me my slope and my y-intercept. We will use this a lot. You will find that the slope, we'll do graphs, collect data, and the slope will have real meaning to us. We usually don't use the RMSE and the correlation. But this is a pretty good fit. Real world data will almost never exactly fit how you want it. Let's do another example. Let's go, I think this one should give me the, let's go back to table. Yes, so this is the table I want. Okay, it's a different data set. So again, I go back to one graph. I'm going to click on the minus to close that down. I want to shrink it up. Then I highlight it, and I'm going to show you the difference between when I choose a power and I add that. It tells me my A is 6.4 and my B, my exponent, is 1.983. That's almost 2. It's going to turn out in most of our physics equations you will never have an exponent that is really 1.983. So to really see what's going on, it's often better to pick variable power, which allows you to pick your exponent, which is almost always 2, not always, but almost always. And we see that changes, so now we have a 6 and a 2.0, which actually turns out to better fit the data I put in. Okay. Real quick, one last thing to show you. We're also in a minute, you're going to have a video in a little bit. Okay, I had a little hiccup. I've got it fixed. I wanted to show you how to insert. So if I click on the 1 and I get the whole row, I can click on insert. Then I could put zeros in there. I put a 0 on that one and a 0 on that one. And now I can put my my keyboard down, then I can go back to one graph. Now to get rid of that, I can click on it. I want a different one. I just delete it. It doesn't delete the graph, it just deletes the line of best fit. You do not have to squeeze it in, as long as you can get them all the dots highlighted. Then I click on the highlighted area, and again I can do a power or a variable power, either one. So I just wanted to show you how to insert, align, and add zeros, because you're going to be asked to do that on the worksheet, and you'll find that doesn't work well. On the Texas Instruments, that will cause a problem with the power function. The Texas Instrument does not have the variable power, which you will see in a few minutes. So that concludes our introduction to graphical analysis.